Good morning, professors and audience. I'm Junyuk, and today I will present my master thesis titled Analyzing Choice Behavior and Economic Valuation of Hub Airport Service Quality for Millennial and Generation Z Transport Passengers. This thesis examines how young transport passengers evaluated Hub Airport service quality and how their preferences can be translated into monetary values for airport service investments and policy planning. The presentation is organized into 5 parts. I will begin with the research backgrounds and objectives. Hub airports are important because connectivity is one of the key competitive assets in global air transport network. As air travel demands continues to grow, attracting transport passengers becomes increasingly important for hub airports. However, contemporary hub airports face strong fiscal and regulatory constraints. This constraint limits the possibility of expanding connectivity through physical infrastructure alone. This creates the problem of network undersizing, where the actual hub network may remain below the socially optimal scale. Traditionally, airport congestion and capacity problems have been addressed through supply-side interventions. For example, physical expansion can directly increase capacity, but it requires high construction costs and often faces political and land use constraints. Air traffic control enhancement and scheduling optimization can improve operational throughput, but they are still limited by fixed airport capacity. Congestion pricing and slot allocation mechanisms can improve the efficiencies of scarce capacity, but they may also reduce marginal connections or reinforce incumbent dominance. Therefore, the main point of this slide is that supply-side measures can generate efficiency gains, but they may not fully restore a socially optimal connectivity. In this thesis, I define airport service quality as a demand-side strategy because many service attributes are directly controlled by airport operators. The mechanisms work as follows. First, a better service quality improves passenger utility and the transfer experience within existing infrastructure. Second, this can strengthen transport passengers' preference for hub airports and increase revisit intention. Third, a better passenger experience can also increase non-aeronautical revenue through retail, dining, and other commercial spending. Therefore, airport service quality is not simply an amenity. It can generate measurable welfare gains and may support hub competitiveness without requiring immediate physical expansion. This study focused on transport passengers for 3 reasons. First, they are a strategic segment for hub airports because transfer traffic is directly linked to hub competitiveness. Second, transport passengers usually spend more time inside airport terminals than origin destination passengers. This means they are more exposed to airport services and are more likely to generate non-aeronautical revenue through dining, shopping, and other activities. Third, transport passengers are not homogeneous. Short transport passengers are usually time-pressured. Layover passengers experience the airports for a longer period, and stopover passengers may interact with the city itself. Because these contexts differ, their service preferences may also differ. This thesis specifically focused on Millennial and Generation Z passengers. These generations are important because they are emerging core customer segments in future air travel demands. They are also more cost-conscious and tend to have lower willingness to pay for non-stop flights. This makes them more open to indirect itineraries, including transfer and stopover options. At the same time, they are more dependent on digital services, expect real-time information, and tend to show stronger interest in environmental values and experience-oriented travel. Therefore, younger transport passengers are an important group for understanding future hub airports' competitiveness beyond traditional factors such as fare, flight time, and frequency. Based on the literature review, I identified 4 major research gaps. First, most airport choice studies focus on origin destination passengers, while transport hub choice remains less explored. Second, previous studies often treat young travelers too broadly and do not sufficiently examine preference heterogeneity among Millennial and Gen Z passengers. Third, the role of airports as micro-destination is underexplored. First, most economic valuation studies in aviation focus on airline-controlled attributes, while terminal-level airport service attributes lack standardized monetary benchmarks. These gaps motivate the integrated preference and valuation framework developed in this thesis. This thesis has three research objectives. The first objective is preference identification, to identify which airport service attributes influence young transfer passengers' hub choice and how these preferences differ across transfer, layover, and stopover groups. The second objective is economic valuation, to convert utility-based preference estimates into monetary values using meta-analysis and benefit transfer. The third objective is policy scenario evaluation, to compare digital-focused, human-focused, and orient service investment strategies and to estimate their welfare effect by passenger segment. The first step is the SB survey. I designed a status preference experiment using 7 airport services. The second step is PMXL modeling. The Panel Mixed Logit model estimates airport service preferences while accounting for individual level heterogeneity and repeated choice tasks. The third step is meta-analytic valuation. I conducted a meta-analysis of 28 empirical valuation studies to derive a shadow price of airport service utility. The first step is benefit transfer and marginal WTP estimation. Finally, I conduct policy scenario simulation using the log sum welfare calculation methods to compare different service investment strategies. Next, I will explain the survey design and choice modeling methodology. The SB survey was conducted using rhyme survey and provided 11 language versions to reach a broader group of international respondents. Initially, 719 responses were collected. After removing incomplete or invalid responses, 621 valid respondents remained for analysis. Since each respondent completes 9 choice tasks, the final data set included 5,589 choice observations. The survey was structured to capture how Millennial and Gen Z passengers choose between hypothetical transfer hub airports with different combinations of service attributes. The SB experiments included 7 airport control service attributes. These attributes were grouped into 3 categories: digital infrastructure, human services, and experience and values. A key point is that these attributes are directly or indirectly manageable by airport operators. Therefore, the research can provide practical implications for airport service planning. To construct the choice experiment, I used a D-efficient design generated by engine software. The final design includes 54 choice tasks divided into 6 survey blocks. The blocks were assigned to 3 transfer contexts: transfer, layover, and stopover. Each respondent completes 9 choice tasks. In each task, respondents were shown 3 anonymous airport alternatives, airport A, B, and C. An opt-out option was also included, allowing respondents to choose none of the airports if no alternative was attractive. The design allows me to estimate how each service attribute affects transfer hub choice. For the choice model, I used a Panel Mixed Logit model rather than relying on a standard MNO model. The MNO model assumes fixed taste parameters, meaning that all respondents are assumed to share the same preferences. In contrast, the PMXL model allows random coefficients, so it can capture individual level preference heterogeneity. It also accounts for the panel structure of the data because each respondent answers 9 repeated choice tasks. This is important because Millennial and Gen Z transfer passengers are not expected to have identical preferences. Across the full sample and transport type subgroups, the PMXL model shows better fit. For the first sample, the McFadden's Dow R-scales increased from 0.0258 in the MNO model to 0.17 in the PMXL model. The same pattern is observed for transfer, layover, and stopover passengers. Based on this improvement, I selected the PMXL model for final preference interpretation. Now, I will present the preference result. For the first sample, the most important service attributes are high-speed free Wi-Fi and friendly airport staff. High-speed free Wi-Fi shows the strongest positive effect, indicating that digital connectivity is a core service expectation for young travelers. Friendly staff performance is also highly valued, showing that human service quality remains important even for digitally native generations. Full airport digital services also increase utility, suggesting that integrated mobile-based services are attractive to young passengers. In addition, city tour availability and strong environmental policy implementation show positive effect. This implies that young transport passengers evaluate hub airport not only as transport nodes, but also as service and experience platforms. The segment-level research show clear differences across transport type. For short transport passengers, Wi-Fi, friendly staff, and city tour availability are important. Interestingly, basic English communication has a negative effect for this group, which I will explain later as a paradoxical finding. For layover passengers, digital services are especially important. They show the strongest response to full airport digital services, digital navigation, and Wi-Fi quality. This makes sense because layover passengers spend more time inside the terminal. For stopover passengers, human service and English communication become more important. The key message is that a one-size-fits-all service strategy is suboptimal. Transport passengers are time-pressured. Therefore, they value immediate support, Wi-Fi access, and clear service signals. Layover passengers spend more time inside the airport. As a result, they place strong value on digital services, navigation support, and reliable Wi-Fi. Stopover passengers interact more with the city and the broader travel experience. Therefore, they place relatively greater value on human support, English communication, environmental policy, and city-related services. This confirms the need for service investment strategies differentiated by transport context. Two findings are especially interesting because they are not simply linear. First is the basic English mismatch. For time-constrained transport passengers, basic English communication by staff has a negative effect compared with poor English communication. I interpret this using expectation disconfirmation theory. When passengers are told that staff have basic English ability, they may expect that essential communication will be possible. If the expectation is not met in urgent transfer situations, dissatisfaction may become stronger than when poor communication was expected from the beginning. The second is the city tour halo effect. Transport passengers show a strong preference for city tour availability, even though they may not have enough time to actually use the service. This suggests that city tour availability may work as a signal of airport city attractiveness and overall service quality. In other words, airport services can influence hub choice beyond direct functional utility. Next, I will explain how the preference results are converted into monetary values. The PMXL model provides utility coefficients, but these coefficients are not directly interpretable as money. For investment decisions, airport operators and policymakers need monetary metrics. They need to compare the value of service improvements with investment cost and evaluate whether a service project is economically justified. Therefore, this thesis converts utility into three monetary indicators: marginal WTP for individual service attributes, a shadow price of airport service utility, and scenario-level welfare gains. To convert utility into money, I derive a shadow price of airport service utility through meta-analysis. The meta-analysis includes 28 empirical valuation studies related to airports and airline services. The study selection follows a Prisma-based screening process. Because stated preference data can involve hypothetical bias, I applied electricity harmonization to calibrate its price sensitivity. The final shadow price estimated was 91.91 United States dollar per passenger. This means that 1 unit of airport service utility is converted into approximately $91.91. Using the shadow price, the utility coefficients were converted into marginal WTP values. For the full sample, high-speed free Wi-Fi generated the highest WTP, about $52.90 per passenger. Friendly step performance also generated a very similar value, about $51.29 per passenger. This shows that both digital connectivity and human service quality are economically important. Other attributes also shows positive WTP in relevant passenger segments. Overall, the WTP results translated passengers' preferences into monetary values that can be compared in service investment planning. To evaluate service investment strategies, I constructed 4 policy scenarios. The baseline scenario represents the current or reference service condition. The digital focus scenario improves digital navigation for airports' digital services and high-speed free Wi-Fi. The human focus scenario improves staff friendliness and English communication. The orange scenario combines both digital and human service improvement. The purpose of this scenario is to compare the welfare effect of different strategic directions. The orange scenario generates the largest welfare gain across all passenger groups. This suggests that combining digital and human service improvements creates the highest overall passenger benefit. However, the relative effectiveness of each strategy differs by segment. A layover passenger showed the strongest response to the digital focus scenario with a welfare gain of $127.66 per passenger. In contrast, stopover passengers gain more from the human focus scenario. For this group, the human focus scenario generates $73.31 per passenger compared with $42.58 under the digital focus scenario. Therefore, the main implication is that airport service investment should be segment-specific rather than uniform. Finally, I will summarize the discussion and conclusion. The findings can be summarized in 3 parts. First, in terms of choice behavior, young transport passengers strongly value both digital and human service quality. High-speed Wi-Fi and friendly staff are the top drivers, but there are also important transport type differences. Second, in terms of economic value, the Thesis translated utility into monetary metrics. The shadow price is $91.91 per passenger, and high-speed Wi-Fi generates a WTP of about $52.90 per passenger. Third, in terms of policy strategies, the welfare simulation shows that the orange strategy produced the largest overall fare gains. However, layover passengers prioritize digital services, while stopover passengers value human services more. Therefore, airport service quality can improve welfare, but investment priorities should differ by transport context. This thesis provides 3 practical policy implications. For airport operators, service investment should prioritize digital and human service as core dimensions. In particular, Wi-Fi quality and staff performance should be considered high-priority investment areas. For hub strategy, airport operators should design service portfolios based on transport context. Transport passengers need time-efficient support, layover passengers need an enhanced digital experience, and stopover passengers need human support and stronger city linkage. For policy evaluation, the WTP and welfare estimate provides a basis for evidence-based service planning. They can support preliminary cost-benefit screening of service-oriented airport projects. This thesis makes 3 main contributions. Theoretically, it extends airport choice research by focusing on transport hub choice, distinguishing transport types, and examining young transport passengers specifically. Methodologically, it develops an integrated valuation framework that combines SP survey data, PMXL modeling, meta-analytic shadow price estimation, and benefit transfer. In terms of policy contribution, it provides monetary values for airport service attributes and demonstrates how scenario-based welfare simulation can support segment-specific investment strategies. Overall, the thesis links passenger preference, economic valuation, and airport policy design. There are several limitations and future research directions. First, the choice data are based on SP scenarios. Although I applied calibration procedures to reduce hypothetical bias, future research should combine this research with revealed preference or real booking data. Second, this thesis focuses on airport control service attributes. Future studies could extend the model by including airline-controlled factors such as airfare and minimum connection time, allowing direct trade-off analysis. Third, the valuation framework is based on a mixed set of airport and airline service studies because airport-specific valuation evidence is still limited. The future research could improve precision using more airport-specific and age-disaggregated valuation data. Finally, this study estimates welfare gains, but does not include detailed capital or operating costs. A full cost-benefit analysis with CAPEX or OPEX data would be an important next step. This concludes my presentation. Thank you very much for your attention. I would be very happy to answer any questions. Thank you.